Okay, so let's talk about concavity, which is, as I was saying in the previous video, is sort of about curving, how a function curves. So I'm just going to draw the four basic pictures of concavity. Here we go. So here's one. Here's the other one. So this is the two ways. That's a terrible drawing. Let me try that again. Yeah, I mean, they were essentially the same. Concave, both of these are increasing, but the way that they increase is different, right? So let's draw two decreasing ones. Here's a decreasing. And here's another kind of decrease. So these are both, let me try to write legibly, increasing but different concavity. These are both decreasing but different concavity. Okay, so what's the different concavity? What is the language that we use for this? All right, I'm going to basically draw the same pictures on the next page. So here we go. Those are my two horribly drawn types of concavity, or increasing types of concavity. So this is increasing, but it is concave. This is what we call concave up. This is also increasing, and it is what we call concave down. All right, so that's two different things. Let's talk about the decreasing models. So this is decreasing, and this one is also called concave up. And then finally, decreasing and concave down. Okay. So one thing that sometimes confuses people is when we start kind of sticking these four pieces together in various ways. So if we can actually like group, we have this, we can group the concavities, right? So if we group the two concave ups together, and imagine doing this, you're going to take this one first, and then you're going to take this one first, the decreasing concave up, and then you're going to glue to it increasing concave up. Okay, so what you have is just pure concave up. Okay. So part of it is decreasing concave up, and the other part is increasing concave up, but overall this is the concave up picture. So, but you have to remember that you can break this into decreasing and increasing parts, okay? All right. That's why sometimes you hear people describe concave up as holding water or like a cup. Now, if we do the same thing with the concave down, we start with this one, and then we glue this one to it. You will have a nice picture. It looks something like this, right? So this is general concave down. I can shade that in how about this? I do this. Increasing concave down, decreasing concave down, general concave down. Okay. But remember, when you're looking at concave down, then you could have increasing concave down or decreasing concave down, or maybe it does both, in which case, you've got, notice what happens if you glue these two types of concavity, or the two increasing decreasings together, then you get a max or a min, right? Okay. So that's a little bit about concavity. Now, what happens if we glue two different types of concavity together? So what I mean by that is, what would happen if I glued increasing concave up, and then I glued to it an increasing concave down? So let's go to the next page. So here's increasing concave up, and then I want to keep increasing, but I want to, so right here I'm going to switch, and I'm going to start going to increasing concave down. So this is increasing concave up. This is also increasing, but it's concave down. So you see we have a new type of function behavior where you basically have this kind of S. And this point right here where you change concavity, that point has a special name. It's called a point of inflection. All right. Sometimes I hear this term, a point of inflection, used in like business speak, and sometimes it's used correctly, but oftentimes I think people just use it as like a buzzword. Well, you know, as you can imagine, that would get on my nerves. But a point of inflection is a real thing that means something, and here's what it means. It means when you have a change in concavity. Okay. So with all this in mind, what we want to be able to do, our goal is, can we figure out a way to identify where a function is concave up, where it's concave down, and where the inflection points are located. So we would like to be able to do that, and then if we could kind of add that to being able to identify where a function's increasing and decreasing and has maximums and minimums, then we could actually do a pretty good job of drawing the function. You know, we'd have a pretty good picture of the function. So that's what we'd like to do. So, right. So let's think about, back to concavity. Let's think about concavity for a minute. Specifically, let's think about, I don't know, let's talk about a piece of a function that is increasing and concave down. Okay. So let's imagine that we're looking at the tangent lines as we move across this function. So I want to pick a bunch of little points, and I'm gonna draw like a little piece of the tangent line at each of these red dots. So there's the piece of the tangent line there, and there it is there. There it is there. I mean, I'm not connecting it to the function because I need it to, I want you to be able to see it, but okay. So these are the tangent lines. Okay. Now we know that because and if we did the first derivative test, we could see all this, but we know that if we have an increasing function, that the tangent lines are going to be positive. So we know that if f prime of x is greater than 0, and vice versa, so we know that f prime of x greater than 0 means that f is increasing. Well, we know that already from the picture, but I'm just kind of reminding you of some things. Okay, so that's one thing we know. But what about the tangent lines? What are they doing? So notice here that in this particular picture, the slopes of the tangent lines are all positive. Yes, we know that already. But what I'm more interested in is they are decreasing. So in other words, if I associated an actual value to each of these slopes, maybe this one would be like positive 20. And maybe the slope of this little line would be like 10. And then by the time I get over here, the slope of this piece might just be like 1, or even smaller. It looks more like 0, really. But so these slopes are positive but decreasing. So like 20, 15, 10, 1 as we move along. Okay. So remember also that f prime of x is a function in its own right. So, you know, basically here's what we're going to do. We're going to try to use the first derivative test on the derivative. So it's actually going to be kind of like the second derivative. So if the first derivative is a function and it's satisfies the necessary conditions, then we could say that if f double prime of x, now I know here I was saying f prime of x is greater than 0, but now I'm talking about the second derivative. If the second derivative is negative, that should mean that the first derivative is decreasing. Okay. But what does it mean that the first derivative is increasing? Well, if the first derivative is increasing, that means, I ran out of room here, but this statement here, this means that f, the original function, is concave down. Now this is true even if I drew a decreasing and concave down picture. In fact, let me draw one so you'll believe me. So here is, so we were looking at increasing and concave down. Here's decreasing and concave down. Okay, so again, let me draw my little tangent lines. What are they doing? All right. So imagine what kind of slopes we have here. It's like this slope might be like, that might be like close to 0. But it's tilting in the decreasing direction. It's going to be negative. These are all going to be negative. But this is going to be maybe like -1. Maybe this one's -5. This one's -10, -15, and so forth. Okay. So the idea, just like we did over here, if the second derivative is less than 0, that implies that the first derivative is decreasing, which in turn implies that the function is concave down. So whether it's increasing or decreasing, if f double prime of x, it seems to be the fact that if f double prime of x is less than 0, then f is concave down. And you can probably guess that we could also say that if f double prime of x is greater than 0, that f is concave up. Okay, now we'll continue these ideas in the next video.